It's really great to be here with you guys. I'm gonna, this talk I put together here is, I'm gonna present a recent paper that I've completed, but I'm gonna try to frame it in terms of what I would call a skills agenda and think about some future directions for it and kind of explain, I guess it sounds sort of grandiose, but the intellectual history of this project and what got me to this point and where I think research on like soft skills and what people can do basically needs to go. So I'm excited to get your thoughts on the paper in particular, but also kind of the larger thought project, so to speak. Is that a soft enough intro? Okay. All right. And it's May 2020 still. It's like the longest, last few months have been the longest months of our lives, but it's still May. Okay. So, all right. So here is, let me just, okay. So here's what I want to talk about today. All right. So first, I want to just talk about, when we say soft skills, what do we mean? What are they? And why are they important? And then I want to talk about some reasons why they might be becoming more important over time and why that might be. And I think it's important to understand why to kind of chart a course for the future. And then I want to just talk a little bit about like if you were actually interested in understanding more about soft skills and how to develop them, and how to measure them, and how to use this idea of soft skills to make the economy work better and hire better and train and develop better, what that agenda would look like. And then I want to talk about a particular paper I've recently completed with one of my students at the Harvard Graduate School of Education named Ben Weidman about how to measure whether somebody's a team player. And I'll tell you exactly what I mean by that later on. And then I want to zoom back out and say, okay, what is this? I want to think about this study we did as like one little boutique study and what will hopefully be an agenda of many studies like it. And I want to encourage all of you guys to do some of those studies. So that's my not so secret agenda. Okay. All right. So what are soft skills? Well, when people say, soft skills, what are the actual words they often use in the next sentence? It's things like teamwork, critical thinking, adaptability, problem solving, creativity, communication, leadership, work ethic. These are all, they're not the same thing. They represent different concepts to many people, but they also mean different things to different people when they say them. When I say adaptability, you think, what is an adaptable person? You might have a different idea in your head than I do. And similarly for teamwork. And I think that's sort of part of the reason why they're called soft skills. We know they're important because employers say they are. Every year, the National Association of Colleges and Employers does a survey of new college graduates. And in that survey, they ask them, what are the things that you most are looking for when you make new hires? And they actually, they'll show a percentage. How many people say they want somebody who's a good critical thinker, who's good in teams. And the top skills every year for the last decade or so have been things like teamwork and communication. And to some extent, things like problem solving and adaptability. And those are generally, they do say we want people with strong technical skills, good analytical reasoning and so forth, but those things tend to rank a little bit lower than the so-called soft skills. And also, interestingly, when you ask employers, how would you rate college graduates on these skills? They also rate them lower on those skills. So college graduates tend to get, A or A- ratings from employers on average in terms of analytical skills, technical skills, but much lower ratings in terms of things like teamwork and communication. And so this is something that employers really want. They don't think they're getting from educational institutions. So that was kind of, for me, the starting point of this project in many ways several years ago, was thinking, look, here's this thing that at least economists are not paying that much attention to, but employers seem to really care about. And they seem to have figured out this is important and are trying to screen people based on it. So what can we say about it? I think, of course, there's a large literature, I've probably forgotten some, just kind of demonstrating a linkage in data between people who score higher on a variety of proxies for what Jim Heckman and co-authors call non-cognitive skill, which is just like definition by absence. So it's like everything that's not captured by a test score. Strong association between those other things like the Rotter locus of control and the LSY and measures of, you ask people about their personalities and things like that. Those things tend to show up as being positively correlated with wages in a variety of data sets and a variety of countries over a variety of periods of time. So it's not like there's some neat mapping between your achievement test score and your earnings. There's a role for other personality traits, and that's been known for a long time. And the other thing, if you just kind of zoom back, I think particularly about working in groups and why soft skills tend to be associated with teamwork and communication. Turns out almost 80% of all US employment is in occupations where the ONET says it's either very important or extremely important to work with others in a group or a team on the job. So group work is the rule rather than the exception. in the modern economy. I don't have similar data from other countries, but I strongly suspect you'd see something similar. That work has really changed fundamentally, become much more interactive and group-oriented and flexible and adaptable. And so if you see this, like employers want this because this is the way work is organized today. So I think, so how they become more important? Well, there's a couple of data points. This mostly comes from my the paper about social skills. You see, first of all, kind of slower growth since about 2000 in the US in jobs that are kind of like require strong technical skills but don't require as much teamwork. Those are often, not always, but often science, technology, engineering, and math jobs, so STEM jobs. And then what you see is relatively fast growth of professional jobs that require college degree but are not kind of STEM. They're more team-oriented jobs like managerial jobs, you know, working as lawyers, doctors, business analysts, basically a variety of professions that require you to have college level skills but also require you to work a lot in teams and interact with others. And so what I show in my 2017 paper is that this is actually part of a longer run trend that's been going on since probably around 1980 or so, showing sort of faster relative employment and wage growth for jobs that are relatively more intensive in requiring social skills, meaning like they just want you to be able to work in groups and to understand others and things like that. So this is the data from that. This is showing the employment growth in high skilled occupations in the US from 2000 to 2012. This axis is scaled so that like if you look at 0.2 on the bottom, that means that job category grew by 0.2 percentage points as a share of all jobs in the US economy. So computer related jobs, computer science, programming, and technical support grew by about 0.17 percentage points as a share of all jobs in the US economy between 2000 and 2012. That's growth, but it's not that much growth given the importance of the sector, at least in public understanding. And when you look at the category of engineers, all engineers, you actually see those jobs have been shrinking as a share of all jobs in the US economy. When you add all these up, it actually is slightly negative. So STEM jobs are less numerous as a share of all jobs in the economy. But when you look at professional, this is the same axis. So you look at professional jobs that are not STEM, that's where you see all the growth. And so teachers, managers, nurses, health techs, accounting, economists, college professors, 2 for 2. And so what you see is a lot of that growth, that's where the action is in the US economy in terms of job growth. And so I think the first response I used to always get when I showed this data is, well, that's because we can't find enough people to fill these technical jobs. If that's true, you would expect their wages to be bid up. So you'd expect wage growth to be faster for them. That's the supply story. Employment going relatively down, but wages going up, and yet we don't see that actually. So if you just look since 1980, this is wage growth for jobs that are kind of high, low, math, social. The STEM jobs are mostly in the high math, low social category. That's the green line, and you see some wage growth in real terms since 1980, but it's been much flatter than the yellow line and the orange line and the red line, which is jobs that are relatively more intensive in social skill requirements. So higher wage growth than the previous slide showed faster employment growth. If you add the orange line and the red line together, you see that jobs that are above average in terms of the extent to which they require social interaction have grown by about 12 percentage points as a share of all jobs in the US economy since 1980. That's a big number. So it just shows that the economy really is changing. It's tilting more towards rewarding jobs and producing more jobs that require interaction. Okay. So it does look like social skills, soft skills are becoming more important over time. We can see that in the data. So why? Well, one reason, maybe not the only reason, but one reason is technological change. And broadly speaking, if you think about what's happening with how does technology change the labor market? Well, technology on the one hand tends to find ways to replace functions that were previously done by humans. That's the substitution margin. But the kind of second order effect is that if you think about a process of taking a product sort of from start to finish, there are some elements of that can be done by machines. And when you get very productive at those things, you can produce more units if you can kind of unlock the bottleneck in the supply chain. And if the bottleneck is something that only people can do, right? Like meet with a team, have a conversation, develop the product from scratch in a group, those things become more important because if you can scale up that process, you can scale up the whole thing, right? And so that's the complementarity story rather. And I think that's one version of, it's a bit loose, I develop it more formally in the paper, but the idea is, look, if there are some production processes that actually require group interaction or even just require conversation and learning from each other, if you can automate the other steps, that step becomes really important. And so people who can do that are going to become more valued. right? And so why is social interaction hard to automate? Well, it's a process that's pretty easy for people. You don't have to really use the noodle that much to have a 2-minute unscripted conversation with another human being. You kind of just do it. Some of us do it better than others, but we do it. And yet it's actually really hard to write a software program to do that. You know, there are people who try those programs. If you've ever seen them, these natural language conversation things, you know, try to, you know, ask a chat about something, they pretty much suck. Even with all the latest technology. It's not that you can't communicate at all. We've experienced these things when we call customer service lines and things like that, but they're not that pleasant to deal with, and they're nowhere near being as good as people. And so this is something that's easy for us and hard for machines, whereas there are things that are hard for us and easy for machines, like computation, right? Or like playing chess or playing AlphaGo is like it's a complicated programming problem, but it's trivial for machines relative to how hard it is for humans. Okay. So that's the story. And then the other thing is you just see it out there in the world, right? There's thousands of case studies about how work changes when they get ICT, information and communication technologies, and it really does fundamentally change the workplace in ways that favor interaction with others. Okay, so all that's kind of why this is becoming more important. So to me, this says, look, we have this thing we know is important. We don't really understand it. That's why we call it soft skills, because we can't get our hands around it. It's becoming more important. Employers say they want it. It's everywhere in the economy. Like we need as a scientific statement, we need to understand this better. And so what I want to try to convince you of is I think there are really two important challenges to doing that. One of them is about conceptual clarity, right? So when we use these terms, what do we actually mean? What makes someone a better team player? What does it mean to be more adaptable, right? And I think, you know, you might say, well, you know, what does it mean to be smarter? Like we don't have a definition of that. And I agree. But I think you have to start somewhere. And it's much better to say, well, here's my definition of what being good at teamwork is. Now you create a different definition, and let's argue about whose definition is right. And then just use these terms loosely. And every time I say it, you mean something different than what I mean, and we never really make any progress. So science is, it's in some sense about picking a fight by being precise. And so I think we need to start having those fights. And I'm gonna pick that fight in a few minutes. The other thing which is related to what we're doing is measurement. Okay, so I think the status quo, at least in economics, is to kind of use off-the-shelf measures that were never really intended for this purpose, and to say, well, that looks like something that's not really achievement. It's like, you know, how much do you think you have control over your life? Or are you the type of person that usually finishes what you start? You know, these questions that are intended to measure personality characteristics or measure your sense of control over your own life, and use those as like non-cognitive skills. And that ends up becoming a kind of self-fulfilling prophecy, because the reason we call them these is kind of a mishmash of stuff. Whatever we have in the data set, we're going to use that and call it non-cognitive skills. And I think that, I don't want to denigrate that research, because it's very important as an existence proof that other stuff matters, that IQ is not the only thing, achievement's not the only thing, that there are important human capacities that are not measured by traditional tests. But I think my view is we've taken that as far as we can, and we have to start creating new measures of soft skills and new ways to define them and conceive of them and kind of test them rigorously. Okay. And so that's what I want to do. And so in this recent paper, this is with Ben Weidman, it's a paper about team players. So we asked this question, does that concept, like being a good team player, does it exist? Are some people better team players than others? And what makes a good team player? Okay. And if you just look, like teamwork's everywhere in the economy, and it's kind of a puzzle because it's costly to coordinate with other people. It's much easier sometimes when you have a task that's very straightforward. It's much easier to just do it yourself than to work with somebody else, right? And so you might say, well, why does anybody work in a team? Well, that's because some projects are pretty complex and you can't do it all by yourself, and people have different strengths and weaknesses. And so that's why you work together. But then you have to ask the question, well, why isn't the economy just one big team? And that's because coordination is costly. So you coordinate when the benefits exceed the costs. And that's increasingly true because work is getting more complex. So I think there's some literature both in the lab and the field on something that's adjacent to this, which is like the idea of peer spillover. So like if I work next to somebody who's productive, how does that affect my own productivity? It's sort of related. There's a bunch of studies showing that peer spillovers really matter. But in those studies, what you're doing is you're measuring individual productivity, and you're saying, does person A make person B more productive? But that really only works in the limited number of settings when you can measure people's productivity as individuals. There's actually not very many jobs where you can do that. Ed Lazier has a classic study about, I don't know, whether you can, these like installers for windshields on cars, right? And shows that when you pay people based on a piece rate, rather than paying them per day, they install windshields faster. And that's great because you actually know exactly how productive somebody is because you can measure the time it takes them to put a windshield on. But most jobs aren't like that. You know, how do you measure my productivity? How do you measure the productivity of a consultant or anybody that works in a large corporation, right? We work in groups. The work product is kind of ambiguous. And so it's not enough to just measure spillovers. You have to kind of, and you see these studies always focus on kind of narrow jobs where productivity can be compartmentalized. Kind of the whole point is you don't want to design an organization where productivity is compartmentalized because you want to take advantage of synergies from group work. So on the flip side, there's also studies of like what makes groups more effective. You know, there's this great work on collective intelligence that comes out of MIT. There's a bunch of other studies on like what are the characteristics of effective teams. And those have the opposite problem, which is you can figure out what teams are good and what teams are not so good, but you can't decompose that into the contributions of individuals. You just sort of have this like black box, this like amoeba of a team, and you don't know who's actually, is it that one person is really driving it or two people, or is it something about the chemistry of the people together that's kind of sui generis, right? And so we want to try to kind of break into this by asking the question, when you assign somebody to a team, does that team perform better than when somebody else is assigned to the team? And is there a durable characteristic of an individual that says when you add that person to the team, that team is more productive than it otherwise would be? And that's what we're interested in trying to evaluate here. So here's what we're going to do. We're going to introduce a new way to measure an individual's contribution to a team. And I'm going to explain it to you in words and then kind of show you the statistics, I guess, or the measurement framework. So the key thing we need, two things really. One is that it turns out that in order to figure this out, you need to randomly assign people to teams, not just once, but a bunch of times. And the reason is that if I just form a team of people and I measure that team's productivity, I have this problem where I can't reduce it to the contributions of individuals, and I don't know whether it's just kind of about the group chemistry. But if I say, okay, I'm going to take Seth and I'm going to assign him to a bunch of different teams, team A, team B, team C, team D, and every time we do that, the team is better than you would otherwise predict, then Seth's the team player, right? Because whatever the composition of his teammates, he's making the team better, or worse. Okay, sorry, Seth. The other thing that's important to do here is you really want to have very good controls for people's individual ability to perform whatever assessment task you're given, right? And the analogy we give in the paper in here is like if you are a chess grandmaster and the task is playing chess, I can add you to a team and you're going to make the team better, but that doesn't mean you're a good team player. It means you're good at chess and the team is playing chess, right? And so what you want to ask the question is not just are people making teams better because they're good at the task? Are they making teams better because they contribute to the chemistry of the group or they facilitate communication among individuals? In other words, is the team better than the sum of its parts when you're on it? Okay, and to do that, you really need to carefully control for people's individual skills. So those are the two keys, as I'll explain more in a second. And so what we're going to do is we're going to conduct a lab experiment in 2 stages. And as you'll see as we get into this, the experiment is quite baroque and complicated. And so after I wrote the paper on social skills, I spent a couple of years trying to convince a company to do this in the field. And when you actually write down what you need, it's pretty complicated. And most people don't want to randomize assignment of people to teams in high stakes situations in the way we wanted. And so we did it in the lab. But high on my agenda is to do something like this in the field. So we first measured people's performance on individual tasks. So we gave them some tests. We measured their IQ. We measured their social intelligence. I'll explain how in a second. Personality characteristics, the big 5, a bunch of stuff. And then we had them perform an individual version of the things they were later going to do in groups. So we could get a good measure of their individual skill. And then in the second stage, we brought people into labs together. And we randomly assigned them to 3-person teams. And we measured a group's performance on similar tasks that the individuals did. And because we had the individual scores first, we could generate a prediction for how well the group would do given the skills of the team members. And then some groups are going to outperform their prediction, and some are going to underperform their prediction. And so what we do is we say, well, when we assign a person to a team, does that team consistently outperform its prediction or underperform its prediction? And that's our kind of functional estimate of who's a good team player, right? So, and I'll show you the math on that in a second. Okay, and so that's our definition. Our kind of, you can argue with it, but our very precise definition of a team player is somebody who, conditional on their own skill, makes the team more productive when you are assigned that person to the team. And then in the second step, as I'll describe in a second, we ask, what are the characteristics of good team players? And that's kind of like the payoff, the interesting part. The other thing is all of the things I'm about to show you were pre-registered. This is our AEA trial registry number. It's important because this is kind of a, as I said, strange experiment. You might be worried, like, how many things did we test? How do we do it? And so we wrote down all of the whole methodological approach, all of the tests we were giving, what were our main outcomes, et cetera, and put it all in the pre-analysis plan. And I'm more or less going to show you all of our pre-registered analyses. There's some that I don't have time for, but all of the main results we had were pre-specified. Okay, so by the way, should I be taking questions throughout? I didn't say. Should I see them in the chat?
It is really up to you. And if you like, you can take clarification questions. If not, you can leave it all to the end.
I normally like to take questions throughout, but why don't we leave it to the end just so we can do it, like people can ask them rather than type them in, and I can call on people. That's more fun. I'm actually kind of close to being done.
All right, great.
Okay. All right, so this is how it worked. I'm happy to show you guys in the Q&A more details on the test, but in the interest of time, I'm not gonna show you like what all the individual tasks were. But the important thing you need to know is the individual tests we gave were these problem-solving tests, the one called the Ravens, which is a test of nonverbal intelligence. It's widely used to measure IQ. And then something called optimization, and then a memory task. And these are like kind of related to, the tests were designed so that you can do them as an individual, but actually, if you're smart, you can do them better as a group. And so we gave people these tests, and then we brought them into the lab, and again, repeatedly randomly assigned them to teams in 2 different lab sessions. So each person got randomized 4 times to a different team, and the teams performed a group analog of that. So this is a kind of schematic of how it worked. And we designed it so that you would never see the same test question, or see, the reason it says battery B, C, D, and E is because we wanted to make sure that people didn't learn by getting the exact same thing twice. So basically they did a different optimization problem or a different memory problem each time in a pre-specified order. Okay, so we had 434 people complete the individual tasks. About a quarter didn't come in for the second phase, which is fine because the randomization occurs in the second phase. And we had a little lab snafu where we lost some sample, but we mostly got people to come back. It turns out people really liked our experiment. They called it the super teams at the Decision Sciences Lab over Harvard. And people I guess a lot of these lab experiments are pretty boring. They're like eye tracking studies and things like that. And so ours was more fun. So we had a lot of people coming back. And our study sample was like obviously disproportionately the Harvard community, but it wasn't all students. It was about 40% students and 60% the population of Cambridge. Okay, so what are we gonna do? So just to, again, like I think I said a lot of this already, but let me just skip to the math. Okay, so here's how we do the methodology. So think about, here are our subscripts. Individuals are indexed by I, groups are G, tasks K, batteries B. And I is just an indicator that's equal to 1 if an individual I is in a particular group G. And X's are your score on the task in the first stage, so individual scores. And we're gonna measure each group's performance kind of by demeaning and normalizing the group score. So like basically the group is gonna perform all these tasks and you're gonna get some score, we call it G, which is a measure of how well the group did relative to other groups. Okay. And so that's kind of the object we're interested in. How do we predict G tilde as the group kind of performance of a group? And how we're going to do that is we're going to condition group performance on individual skills by using this X control. So we're going to say, given the skills of the individuals, how well did the group do better or worse than we would have predicted? And that's the residual epsilon, right? So if the group if it's chess playing, the group has 3 grandmasters on it, the prediction for it based on their individual scores in phase 1 is going to be that they're going to do really well. If they do somewhat worse, they'll have a negative residual, right? So we're differencing out our prediction for how well the group would do based on individual performance, okay? And then we have a couple other nuisance controls, like did the people happen to know each other ahead of time, which has turned out to be pretty rare. Okay, so for each group, because they did 3 different tasks, we're going to take this T hat, which is just the average score across the 3 tasks. And that's the average residualized score. So that's T hat. That's a measure of how well group G translates its individual skill into group performance. So like, is the group doing better or worse than you would predict? That's T hat. Okay. And then what we're going to do is we're going to randomly, and again, this is demean, so it's like controlling for individual skill. And then we're going to say, because we randomly assign people to 4 different teams, we're going to average the residuals T hat across the 4 teams for any individual. So to get this beta hat I for an individual, we say, well, what was the residual positive or negative when you were in your first group? Was it positive or negative when you were in your second group, et cetera? And so people who consistently have positive residuals are team players. That's beta hat. Okay. And of course, if we had enough randomizations, we could estimate the team player index, we call it, for every person in the sample. But we don't. We only had 4. And so that measure is pretty noisy at the individual level. But what we can do is conduct a systematic test for whether beta hat is statistically different from 0. Right? So this is like an excess variance type. It's sort of like teacher effects, if you know that literature. We're saying, is it the case that people differ persistently in their ability to contribute to a team? Which is a test for whether beta hat is significantly different from 0. And so we basically focus on the estimate of the variance. So sigma hat beta is an estimate of the average team player effect across individuals, and we just say, like, how is it distributed, and does it look different from chance? And our main approach is we're going to use a randomization inference procedure. We're basically going to draw placebo groups 5,000 times and look at the actual estimate, the actual spread of the team player effect, and ask how often is it to the right of the null distribution. Okay, I'm happy to go into the measurement more in the discussion if you guys want. But we're just basically going to estimate that. So I say this, we're estimating this is the normal approximation. Not clear the team player effect would be normal, especially since we're estimating a variance. So the normal one is like the most generous standard errors, and the randomization inference procedure is the most stringent. And then we use another approach we call profile likelihood, which is like accounting for non-normality, but is not an exact test. It's still a fitting a distribution. Okay, and so what we find basically is significant, the team player effects exist, that they're significantly different from 0 with all 3 approaches. You can see the normal approximation gives us the smallest standard errors, but randomization, even with the randomization inference procedure, we can pretty strongly reject the null that everybody's the same in terms of making their group better. And that's important. Like, it's not trivial. What it says is there are some people who consistently have positive or negative residuals, that it's not just like, hey, every group does its own thing. Every group has its own chemistry. Every group's unique. No, actually, every time Seth or Lubiga or anybody else goes onto a team, there's something about that person that predicts whether the team will be better or worse, conditional on those people's skills. So it's not just that they're good at the tasks. It's that they're good communicators, or they motivate their teammates, or whatever it is, right? Because we're conditioning out individual skill. And as I'll show you in a second, we can condition out individual skill in a variety of ways. We can be really flexible about it, higher order polynomials, interactions, blah, blah, blah. It doesn't make a big difference. Okay, and so you can see these coefficients in columns 1 to 3, they're all the same, kind of a clumsy table, but you can see that basically whether you're good at the memory task strongly predicts group performance in the memory task. So individual skill really matters a lot, which is good, right? If we basically give people an individual analog of a group task, they ought to line up. And so even conditional on those things, there's this team player effect. And so another way I can show you this is to say, what is the team player effect when we control for different things in that X vector? And if you look at column 3 is showing you like the team player effect with no controls at all. So not controlling for individual skill. That is allowing the fact that the chess player is a grandmaster to just directly enter his ability to be a team player, his or her ability to be a team player. That increases the team player effect to 0.244, which is much bigger than the spread of the team player effect when you condition on individual skill, but it's still about half, right? So what that says is, if you kind of compare the coefficients and take the average of these 3 task-specific skills in column 1, you get something like 0.2, and column 1 is 0.127. So another way to interpret these magnitudes is to say, if you are a better team player, that's worth about as much, worth about 60% as much as just being good at the task directly, right? Because the coefficient on that is 0.2, the coefficient on the team player index is 0.12, that's 60%, and they're both standardized, so they're on the same scale. So it's actually a big effect. It's actually saying somebody who's a good team player makes their team better almost as much as just being good at the task at hand. Okay, the other thing that's interesting to note is if you look at column 2 and you just control for people's IQ, you see the team player effect is 0.17 rather than the task-specific skill. So it looks like actually being good at the particular tasks is kind of worth more in a prediction sense than just being smart. On the other hand, you look at column 4, and we look at personality factors, like whether you're agreeable or extroverted or conscientious. Those things have no predictive power at all for the team player index. There's a lot of variation in people's stated personality characteristics, but it doesn't have any predictive power for whether somebody's going to be a good team player. I'll show you that in a second. Okay, so let me just show you show you those right now. So if you look at what makes somebody a good team player, first the column on the picture on the left shows you the correlation between beta hat, which is the team player index, at the individual level and an individual's IQ as measured by the Ravens test. And column 1 below shows the coefficient is like the slope of that figure. So it's 0.05, it's not significantly different from 0. What this says is after you control for the impact of individual specific skill in the team player index, IQ has no predictive power for who's going to be a team player. It's uncorrelated. So think about it again, like, yeah, I'm good at the shapes task. That makes me a better team player. That's fine. But once you condition that out, it's not like people who are just generally smarter or better team players. Okay. Whereas if you look at column 2 in the left-hand panel, which is the uncontrolled team player index, there you do see a strong relationship between IQ and being a good team player. But all of that is mediated through whether you're better at the task at hand. If you look at the right-hand side, this is your score on a test called the Reading the Mind and the Eyes test, which is a widely used test of social intelligence. It was actually originally developed by Simon Baron-Cohen, who's a well-known autism researcher, to diagnose high-functioning autism and Asperger's in otherwise high IQ adults. It turns out your score on this test, I'm going to tell you more about the test in a second, strongly predicts whether you're a team player, even conditional on task-specific skill. That's column 1. So the slope of that line is 0.166. It's strongly different from 0. And it persists, as you can see in the columns, regardless of what we control for. Column 3 is, like I said, the kitchen sink. So you're controlling for lots of different things that might predict being a good team player. So the RMET turns out to be the thing that really pops out more than anything else, more than personality. You see, this is, this is the personality characteristic. So this is agreeableness, conscientiousness, extroversion. What you see is just nothing. Those things are completely uncorrelated with being a good team player at all, regardless of specification. So what is the Reading the Mind and the Eyes test? It's 26 items that are like this. So you ask people, you show people images of eyes, and they have to identify the emotion that's expressed. And I should say, by the way, in our test that we administered, there was a link to like a dictionary. So if you didn't know what the word meant, you could look it up. And so people score on this test predict whether they're going to be a good team player. That's kind of the main punchline. And again, that was a pre-specified test in our paper. So it's not correlated. Being a good team player is not correlated at all with gender. It's not correlated with years of education. It's not correlated with age, and it's not correlated with race or ethnicity. Now, the standard errors on this are pretty big. So we'd love to replicate this in like a sample that's 10 times as large and see what turns up. But still, we don't find anything here. Interestingly, if you kind of ask, okay, throw everything in the kitchen sink, I was showing you bivariate correlations a lot of times, but what happens if you control for everything? What you see at the punchline of this table is that the Reading the Mind and the Eyes test is the only thing that predicts being a good team player. And actually, if you compare like column 1 to column 4, and you look at the R-squared, just putting in the RMET gives you a higher a better fit than throwing everything else in without it. Right? So it strongly predicts, strongly, it's a 0.028 R-squared. I don't want to say strongly, but it in a relative sense, it predicts team performance much more than anything else. Okay. So the last kind of result I want to tell you about is that we did this validation thing where we basically gave people 3 different things, and we had a 4th task that we held out. We didn't use it to estimate the team player index. It's kind of like our out of sample prediction. And this is this task called cryptography. And we held it out because it's kind of well known in this teams literature to be something that's like much more efficiently done in a group because it's pretty complicated. And if people work together, they can do it well. Again, I'm happy to get into the tasks more in Q&A. But what we find basically is that pretty good evidence that people who score higher on the Reading the Mind and the Eyes test, that's column 1, or people who are better team players tend to make their groups better out of sample on this cryptography test. In other words, like it's not kind of what's the word I'm looking for? Kid brain. It's not oh my gosh, I'm losing it. It's not circular. This test is not being used to construct the team player index, but it still predicts it out of sample. So we call S social skills, which is just the average of the beta hat and the RMET. We find that it strongly predicts groups' performance on a cryptography test, meaning the average score on somebody's social skill index. Again, so you take people's average score on the RMET and their average estimated team player index, take the average of those 2 things, and then take the average across the group, and that predicts group performance. That's what this table shows you. And personality scores don't really predict performance. And if you if you look at column 5, where we have both social skills and IQ in there, they have the same coefficient. So that's kind of another way of saying that is, in an out of sample task, social skills are about as important as IQ in predicting group performance. So one more kind of nugget you might be interested in, why is this happening? Well, we're doing some follow-up work to try to understand what makes somebody a good team player in a more qualitative, richer sense. But one thing we can see is some suggested evidence that effort might be a key margin. So good team players induce their teams to exert more effort. For one reason is if people who we estimate to be good team players, their groups are less likely to rush, meaning they finish long before their allotted time. They're more likely to take their full time. And also, in the memory task, the way it worked is most teams, it turned out that almost all the teams basically said, okay, you do this subtask, you do this subtask. So they kind of divided it up. And the only thing was we have to kind of work together to decide who's going to do what. And so that's an example where it's group work, but it's kind of individuals doing their own thing in terms of the actual production. And even on that task, we see that team players increase performance of teammates. All right, so what that suggests is it's not like I'm telling you how to do it. I'm actually saying, let's get this done together. And then you're doing it on your own and you're more motivated to pay attention because you're on a team with a team player. So it's like kind of suggestive evidence, but we do find some evidence of it. But stay tuned, more to come on that. So why does this paper matter? I think this is a pretty general methodology. I mean, we had a particular thing we were going for, but the idea that you can repeatedly randomly assign people to groups and figure out how they contribute to group performances, I think could be used in a lot of different ways. And this is a roadmap to doing it. So I think also, there's a lot of studies showing indirectly kind of a wage equation that like social skills or soft skills pay off. And this is, I think, a pretty direct mechanism, because if you find people that contribute more to teams, given how much teamwork there is in the economy, you'd want to pay them for that, right? And so this is, to the extent that employers can observe your ability to recognize emotions in others, they're going to want to pay for it. So this kind of directly establishes that link between social skills and productivity. I think the last thing is kind of a practical contribution, which is like, maybe people should use this to try to figure out who are the good team players. Like this could actually have value, provided that it generalizes outside of a lab. Okay, so more work is needed, but I think, this is a roadmap to figuring out more about what makes people good in group settings. So in terms of what I want to do next and how this connects to the larger addenda, I think already starting discussions to kind of try to do this in a larger sample, right? Just straight up replicate it and extend it in a variety of different directions. So one is like, what is this motivation channel? How does it work? We're doing some work. We actually recorded all of the, or not all of them, a lot of the group interactions, and we're gonna code them up and kind of do things like, can people watch thin slices of the videos and figure out who the good team players are and connect it to behavior? So we're working on that now with some folks in the psychology department at Harvard. You might think about other samples, not just students at Harvard or not just Cambridge, and other types of tasks, and then doing it in the field. So I'm working on all that, thinking about how to do that. Happy to talk more about that with some of you guys. Encourage others to do it. And then I think you could do this for other skills. Like, is there a way to think rigorously about what we mean by adaptability and measure it? So that's another thing. Creativity, like how do we measure these skills, right? There's a really nice paper by Brown, Carr, and Schofield. Maybe some of you have seen it, called Cognitive Endurance as Human Capital, where they measure teachers' ability to basically keep students on task and kind of like persevere through difficult stuff, and show that's a skill that can be built and it's related to performance. So that's kind of a paper that's in line with this agenda. I think the last thing I'm interested in is like, okay, well, if we can identify who's a good team player, how do we build that skill in others? Can that skill be improved, right? Can we treat people with an intervention and measure them at point A and point B and find that they actually have become better in a team? I think that has real promise. And maybe the right way to do that is through some kind of simulation-based learning environment or role-playing or something where you get people comfortable with the idea of working in groups and kind of assess that rigorously. And there's some work out there, but a lot of it is, I would say this is a setting where, people always say more research is needed, and it's not always true. But here it really is, because there's a lot of people out there doing stuff in the field. There's very little scientific evidence on what works and how to do this rigorously. And I think that's really where we need to push. Like we need, as researchers, need to chart the course. Okay. And then once we figure that out, I think the application to the field will become pretty obvious. Can you guys hear me? Okay. All right. And so I guess what I'm saying is I think that research has a really big role to play in building insights that are useful for policy or practice, and also just understanding like what is the science of human potential. The thing I'm most excited about is like if we can measure people's soft skills in a rigorous way, we could do things like tell employers, hey, this person does not have the type of resume that looks like they'd be good at this job, but they actually would, because we've built a kind of lab-based environment where we can assess what they can do and help people match to jobs for which they are a good fit. I think the science of that is very underdeveloped and there's a lot more we can do. So that's kind of where I'm headed and what I'm thinking about. And I look forward to your thoughts. Thanks, everybody.
Thank you very much for that really, really interesting talk. I think it's quite different from what we've seen already today, especially the experimental aspect. So that's, great food for thought. So what we're going to do with the questions is that I'm going to first start with various people who've posted a question in the chat and ask them if they'd like to ask their question directly to you. And then we'll see if there are others. So you can either post your question in the chat and I'll call on you, or if we don't have time, Dave can also look at those questions and reply to them by text. And you can also raise your hand. If you click on the Manage Participants button, you should be able to raise your hand. Okay, so the first person on my list is Frank.
Hey, Frank.
This was super interesting.
Thanks.
So the way I've been thinking about what you're telling me is that some people are good at coordinating other people's efforts. So there are several ways in which people's efforts got coordinated in an economy. And the entire business literature has been talking about routines, basically as a way to make sure that even if people don't know how to work together, that it doesn't matter if some team members change, that the team itself would still be productive. So in a firm setting, you actually have mitigating mechanisms for having poor team players. And I was wondering whether you think that how you would see the relation between these routines and people with good team skills. So are they complementary, substitutes?
Yeah, great question, Frank. So I mean, I think there's a lot that needs to be done to understand that better, but I'll just tell you what my instincts are. I think like there's a wonderful paper by Deming and Santos in the JPE called Adaptive Organizations. All you grad students out there should really read this paper, because what it does, it's a kind of theory paper, but what it does is outline the conditions under which you want to develop an organization that is rigorous and rules-based and has standards, versus an organization that's more, where you basically allow employees to have more autonomy and local control. And there's an interesting trade-off between those two things, because on the one hand, you want to control, if you have poor team players, right, you want to design the environment that in a way that forces people to behave in a certain way, in a way that they can be monitored and standardized. But you lose the ability to react to local information that the decision makers at the top of the ladder don't have. And so that's always a second, like kind of rigorous control and accountability is always a second best environment. And you see the same thing in education. Like school accountability is nobody's idea of an ideal education, but it might be better than everybody learning nothing. On the other hand, what you really want is you want people who are intrinsically motivated to give the best education or be as productive as possible. And you want to allow them the freedom to flourish and respond to what's going on in their environment. And so I think what you might see with this is if we could learn a little bit more about which people are good in teams and why they are, then you might be able to allow for more autonomy if you had a group of people that you could assign with some knowledge about how they would work in a group. You could sort of free up, and you see like effective corporations and organizations do this. They give their employees more autonomy because they trust that they're going to get more creativity and better output and more motivation out of it. So I think about this agenda that I outlined as like giving more information to firms or other decision makers who want to decide how to organize team production.
Okay, so Seth is next on my list.
Awesome. So again, amazing talk, really interesting. One kind of question I'm left with is, to what extent is what we're seeing that some people are better at like supervising and helping other people do their jobs versus they're better at cooperating and they're better at doing their jobs when they are complemented by others?
Yeah.
Right? So yeah.
Yeah, it's a great question. Yeah.
And maybe one way of getting at that is to look at how being a team player scales with the scale of the group. Because you might imagine a good supervisor can supervise 20 people, but if I'm complemented by other people being near me, maybe that peters out after a couple of people.
Yeah, great question. So we very intentionally did not organize groups into a hierarchy. So actually, one member of the group had to be a reporter, meaning like they just report. And so one thing we tested for is like, is being a reporter correlated with being a team player? And the answer is no. And also like the people didn't know each other. Like the interactions were in some sense very artificial, and were designed to, and the tasks were designed to not be hierarchical. And so we did that because we wanted to get rid of this harder question of leadership, because I think there the external validity is much harder. It's like, well, if you take some people who don't know each other and you say, you're the leader, and you measure how good a leader somebody, like how does that scale to an organization where people, there's some sense of legitimacy that might be different based on somebody's background, et cetera. And so our instinct was, this is not a good setting to tackle questions of hierarchy and authority.
Mm-hmm.
But I'm wrong about that. I think you sort of need something to know each other, or at least have some sense of hierarchy, frankly, that they come in with.
But so, if the effect is coming through me motivating others, I mean, I would call that something closer to leadership than I would call that I'm cooperative and I take orders well.
Maybe. So this is a definitional issue. I mean, leadership can be hierarchical. It doesn't need to be, right? So I guess it depends. But I guess my instinct is, like, we're going to get more information out of this in the audio video project. My instinct is it's the latter, is that from what I've seen, it's people who, so one thing is like, people were not, like, you could just kind of come in and like basically not care that much and like not pay that much attention to the task, because they're kind of like annoying, you know, they can be interesting, but it's also like, I don't want to do this, I'm just sitting in the lab. And so I think part of it is team players to say, all right, let's get this done. Like, you do this. It's not that they're saying like, you, Seth, I'm ordering you to do this. It's more like they're getting you excited about the group task. And I think that does translate, you know, like some people are just more, not more fun, but just like more engaging to work with than others. And so I think that's part of it. I think the other thing is like, and this is why I think the reading the mind and the eyes test may show up as being important. It's like, if the second we sit down, like maybe you're low energy and I'm high energy, and you know, Peter is in the middle, okay? And the question is, what equilibrium does the group get to? Do they get to the Seth equilibrium or the David equilibrium? And so I think like my ability to kind of read how what I'm saying is hitting you is crucial in like getting you more toward my equilibrium. Right. And so that's my instinct, is like people kind of converge, kind of like the way if you walk with somebody long enough, you start stepping in line with them. So the question is like, who's guiding that?
Yeah, that does beg the question though, if the bad team players really have a lot of social impact and they just don't care.
Yeah, I mean, our measure is kind of normalized. So it could be that this is all being driven by a few bad team players rather than some good ones. Like, you know, so much is to be learned about this. But I do think like, and I would never claim that this is the answer. I think like my fondest hope for this is that all of you guys will go do experiments like this and like point out the limitations of this particular experiment. I mean, I think that's how we make progress.
Okay, the next question is from Martin.
Hi.
Martin?
Just had to unmute myself there for a second. Thank you. So a lot of organizations right now, a lot of companies are spending a lot of money on the personality side of this equation, right? Like the big move in hiring practices over the last 10 years has been explicitly towards a more scientific measurement of personality as a way as a good proxy for skills. It kind of sounds like your initial experiment seems to indicate that that's not the move. And
that's right.
Instead, like emotional intelligence needs to be something that we measure. Do you think that this is, I'm still processing, but do you think that there is a alternative way organizations can start thinking about measuring EQ in order for them to make those differences in their hiring practices? Yeah,
great question, Martin. I'm glad you asked it. So I think that one reason why these personality tests may not work is because they're not incentive compatible. I mean, like big box retailers measure conscientiousness. They use some version of the Big Five personality scale to basically, because turns out that when you give those tests to people, it predicts like how long people are going to stay on the job before they quit and whether they're going to steal merchandise from the store and things like that. But there's also websites I used to show at my class that are devoted to teaching people how to game the test, because there's a right answer on the personality test if you know what you're looking for. And so, and I think the larger issue is they're kind of context specific. So one of my favorite examples of this, it's in a paper by Jim Heckman and Tim Kautz about soft skills. They talk about the correlation between conscientiousness across countries. It turns out that if you ask people how conscientious are you, South Koreans think they're not very conscientious compared to the French. But if you look at hours worked per person, South Korean work like 400 hours more per year than the French. And then there's other examples, like Marty West has a great paper showing that when you assess people's conscientiousness in high stakes, like charter schools, like no excuses charter schools, like KIPP schools, the students report that they're less conscientious than students in the public school. Because what they're observing is in their environment, everyone's being pressed really hard and they think, wow, I can't measure up to this standard, but the standard itself is subjective. And so I think how conscientious we think we are depends on who else is around us and our sense of what that word means. Whereas whether you can accurately identify emotions and faces is much more objective and much more invariant to the context. And so I think that's why it's a better measure. It has a right and a wrong answer.
I know I'm probably cheating here, but one last question. The other thing I could see people saying, and my HR head's mind starts clicking, is that this might not be EEOC compliant, right? Like what does it mean for people who, because of disabilities, are not able to be doesn't have as strong as emotional intelligence as other people? Like, is there a thought process behind that? Is that something that you've accounted for in your analysis as well?
Yeah, it's a tricky issue because the question is always, it's not just about absolute bias, it's about relative bias. So there are lots of examples of settings where you give a test to someone, it's racially biased, or it's biased by gender, or it's biased by nationality. And yet using the test reduces bias in hiring because the bias in the test is less than the bias in what recruiters are using in the absence of the test. So David Otter has a classic paper about this, again, using big box retailers. They give this job test to screen potential workers. In the absence of the test, white workers were getting called back at much higher rates than workers of color. The test itself has a bias in it. White people score higher in the test than people of color. And yet once recruiters use the test, racial gaps in hiring narrowed because the recruiters are more biased than the test is. And so I think the question is not, do we have bias in a measure like, and by the way, it's not that I care about the reading the mind of the eye test. That's just the thing that happened to work. I don't think this is about that. I think this is about like measuring skills and asking what it's related to. I think it does open a can of worms, just like IQ tests do, just like SAT does, just like any assessment. But I think the question is always, is it better or worse than the alternative? And here I think I personally think the evidence I've seen suggests there's so much bias in hiring that's qualitative that introducing some quantitative measures is probably going to make things better, not worse. But I think that's something that should be studied, not taken for granted.
Thank you.
Okay, so next we have Stacy.
Stacy.
Or if we don't have Stacy, we have Savannah.
Is that Kadeem?
Yeah. Hey, Dave.
Hey, Savannah. How are you?
I'm using my wife's Zoom. So quick question. I'm wondering how you think of, do you think of social skills as culture dependent? As in, you might imagine that somebody could do really poorly if they're in a minority group, they communicate differently in a particular setting. But if they're in a different context with sort of their in-group, they might seem like they have very high social skills. Yeah. Is that something that you think about? Is there any sort of diversity in your groups with respect to race or other things that you speak to? And then even more broadly, as jobs become more team-oriented, is this something that we need to be concerned about, that like what we think of as leading to good team skills are really like culture-specific ways of communicating?
Yeah. It's a great question. I don't know the answer. It's something that I want to find out the answer to. I mean, I think that's testable, yes. Right? And it's totally plausible that like you could think about it as my ability to work, my team player index is a function of not just kind of something innate, but also like there's some interaction between that and my teammates or whatever. Mm-hmm. One thing we did test is we had a bunch of different pre-specified measures of team diversity and asked whether that predicts group performance. We found nothing on that, for what it's worth. And the literature on that is kind of all over the place. I don't know if there's any firm conclusion we could draw, but we didn't find any evidence of it. I do think what you say it makes a lot of sense. The idea that like I mean, in other words, you know, one thing we found, so in the collective intelligence literature, they often find that women score higher in the reading the mind and the eyes test than men do. And so groups with more women score better. They do better. We didn't find much evidence of that, but like, I think stepping back, one reason for that could be like, you know, maybe a group that has 2 men and 1 woman on it, like doesn't listen to the woman. And therefore it doesn't really matter if she has good ideas about what to do. And so like, there's this, I think, intrinsic difficulty in disentangling the way we treat each other from our estimates of the team player measure. And so that's one reason why I want to do this audio video study, because I think we can try to uncover some of those things. And I just think, again, like I just want to stress, this is one experiment. Like I think we should, I'm trying to keep an extremely open mind about what it means. And I just hope that, like what I'm really trying to push is that we should be doing more work like this, because the value of the lab is that you can very carefully specify the hypothesis you're trying to test. And it's not going to end the debate on a question, but it can start the debate. So like somebody might say, I don't believe Deming, I'm going to do a bigger experiment in the field. And if the experiment doesn't replicate, fine. But that experiment never happens if I don't do this study. So I think that's where we should all be going. Like, I don't have an agenda with this. I just think we ought to be more, if we care about soft skills, we ought to be measuring them more precisely and like thinking about ways to test our theories.
Awesome, thanks.
Okay, so I think the last question will go to Catherine.
Hi, Catherine.
Bit provocative, but where do you think technological capabilities are on soft skills?
I'm sorry, Catherine.
Okay.
Can you repeat the question, please?
I can read the question, yeah. Sure.
Yeah, maybe. Super.
Sure, I'm sorry. Thanks. I can read it. I'll answer the question. Okay. Do you think it is easier to cheat on technical capabilities or on soft skills, and why? Good question. I try never to think about cheating. I would never do anything like that. No, I think, I don't know the answer. I mean, cheat, you mean cheat in the sense of like give the right answer? I think part of what we're trying to do is to design measures that are hard to cheat on. You know, like this example I gave of the test for personality characteristics is like, it's not, I don't know if you want to call it cheating. It's just like people can give the answer that they think they want people to hear. Whereas if I'm giving you a test and there's a right answer or a wrong answer, you either know it or you don't. And so I think part of the reason why we're kind of stuck in this soft skills literature, if you want to call it that, is because we have a bunch of measures that like are gameable, or you can cheat on them, or like they mean different things in different contexts. And so I think the main value to me of this reading the mind and the eyes test is that it has right and wrong answers, not so much that that's the only way to measure. And like my psychologist colleagues tell me that it's not really a test of what they call theory of mind. It's really more about emotion recognition. And like, it's not like you could imagine be good at this test, but being a bad team player, because like, yes, I can recognize the emotion in you, but I don't care because I'm a psychopath. You know what I mean? So like, it's not good enough, but I think it gives you something that the other measures don't. And so I think that's where we ought to be pushing. I think inability to cheat is synonymous with context invariant and like psychometrically valid.
Brilliant. Okay, so I think we're right on time. So I think I'm going to hand over. So first of all, thank you very much, Dave, for joining us this evening. It was most certainly a pleasure, and we really enjoyed your presentation and the Q&A.